Bismillahirrahmanirrahim. Next, inshallah, we'll review here two special triangles that we have also seen before. And this is imperative knowledge, and we can't go very far without this mastering this bit of knowledge. So the two special triangles, of course, are the 45 degree 90 triangle, and there's a 30, 60, 90 triangle. So this is 30 degrees and 60 degrees and 90 degrees triangle. So these are right triangles again. So this is a right angle, and this is a right angle. So these are two very special right triangles that we're going to need to know very well for these future discussions. Okay. So if you recall, for a 45, 45, 90 triangle, these two sides are congruent. Okay. This is the base angle theorem, if you recall. So if the base angles are congruent, then the opposite sides are congruent. Okay. And the converse is also true. If the opposite sides are congruent, then the two base angles are congruent. So that we remember that from the base angle theorem from geometry. And that's important to understand, because sometimes in tests and things, they might not give you, like, you know, the angles. They might give you a right triangle with two sides that are congruent like this, and the implication that this is a right 45, 45, 90 triangle, and then they would give you something like this, and you're supposed to figure out these two sides. So it's important to understand that they might not give you the angle. Sometimes they might imply that this is a 45, 45, 90 triangle by giving you the two sides being congruent. Then we recall that if such is the case, such is the scenario, then the sides are x, and this side is x square root of 2. In other words, if you're given a 45, 45, 90 degrees triangle, and this side is given to be 5, okay, then this side would be 5 also, and this side would be 5 square root of 2. Okay, that's easy enough. So sometimes I think it might be easier if you just write these as a 45, 45, 90 triangle would be x, x and x square root of 2. Okay, so that's very important. The other aspect of this is, if you have to appreciate and you have to learn to see these as, okay, if this is x and this is x, this is going to be x square root of 2. In other words, whatever this number is, you're going to have to multiply it by square root of 2 to get the hypotenuse. On the other hand, if the hypotenuse is given, if you want to get one of the legs, you divide it by you divide by square root of 2, right? So if you are given, for example, a 45, 45, 90 triangle like over here. All right, let's see. Let's have a 45, 45, 90 triangle. All right. Then let's say this side is 10 square root of 2. Okay, to get from this side to this side, we have to divide the hypotenuse by square root of 2. Okay, so this side would be 10 square root of 2 divided by 2 by square root of 2. And I made this easy, of course, and this side would be 10. And this side would also be 10. Okay, to give another example of the same, but perhaps one that's not as simple, let's say this side is 5, okay, and you want to find what these two sides are. Then you have to divide this by square root of 2. So this side would be 5 over square root of 2, and this side would be 5 over square root of 2. Now, it's not mathematical matters, or it's not must have to have square roots in the denominator, so we have to get rid of the square root, and that's called rationalization of the denominator, if you recall. The way you get rid of the square root is by multiplying the denominator and the numerator by square root of 2. And this will give you 5 square root of 2 over square root of 2 times square root of 2 is, of course, 2. So this is a more, proper way of writing the same thing. But that's the idea being, how do you get to the sides if you're given the hypotenuse? So you should be able to go from here to here to here, here to here to here, etc. Okay, so this is one very important triangle. The other, of course, is the 30, 60, 90 triangle. And the 30, 60, 90 triangle, I remember, it's like almost like an echo in my mind, my high school teacher saying the side across from 30 is half the hypotenuse. The side across from 30 is half the hypotenuse. If the hypotenuse is 2x, the side across from 30 is x. And this side is x square root of 3. Okay, so the three sides are, so you start with the hypotenuse, label that to be 2x, and to get from there to there, you divide by 2, and then to get from here to here, you multiply this by x. So if you do this as an example, okay, so this is a 30, 60, 90 triangle. So if you're given, for example, that this is 10, the side across from 30 would be half the hypotenuse, so this would be 5, and this side again would be 5 square root of 3. Okay, or as another example, let's say this is 8. Well, to get from here to here, see, you start from here to here, you have to divide by, how do you make x square root of 3 into a x? Well, you have to divide by square root of 3, right? So to get from here to here, you have to divide by square root of 3. So this side is going to be 8 divided by square root of 3. Again, you rationalize the denominator. So this is square root of 3 and square root of 3. So this becomes 8 square root of 3 over square root of 3 times square root of 3 is 3. So we have that. Now to get the hypotenuse, okay, you take x and you multiply it by 2. So this 2 times this value, 8 square root of 3 over 3 will be the hypotenuse, which is going to be 16 square root of 3 over 3. Okay, so this is very, very, very important. Okay, now the reason this becomes very important because this leads directly to our trigonometric ratios and the stuff that we have been talking about previously. But before I do that, so let me just rewrite some of this. Now this must be like second nature to you. You have to know this 100%. Now what I would request you to do is of course some examples with this, but I'm going to give a very special scenario of a 45, 45, 90 triangle and a very special scenario of a 30, 60, 90 triangle. So these are still going to be 30, 60, 90 triangles. Yeah, the best I can draw here. So it's 30, 60, 90 triangle. And this is going to be a 45, 45, 90 triangle. Okay, 30, okay, 60. Okay, now the special scenarios, the special case of a special case, it was like special case of a special case, is, okay, here's the, what if the hypotenuse is 1? Let's do it, let's work this out. I want to know what the sides are, okay? So if this is a 45, 45, 90, if you want to go from hypotenuse to the side, I have to take 1, I have to divide by square root of 2. If the hypotenuse is 1, then this side would be 1 divided by square root of 2. Okay, so let's rationalize this denominator. Again, multiply top and bottom by square root of 2. Okay, then you get square root of 2 over 2 times, square root of 2 times square root of 2 is 2. And this side is going to be, again, square root of 2 over 2. Alright, so that's one special scenario. Okay, what's the other special scenario, you ask? Okay, well, okay, fine. That's not that different than this one. What if the hypotenuse is 1 over here? Okay, what are the sides? Okay, alright, let's see. The side across from 30 is half the hypotenuse. From here to here, that's easy enough. That's going to be 1 divided by 2. And from here to here, it's going to be this times the square root of 3. It's going to be square root of 3 over 2. Okay, so these are super special cases of special triangles, and the special cases are when the hypotenuse is 1. Okay, now this is going to lead us to our future conversations with the unit circle. This is so sufficiently important that I'm just going to do this one more time. Okay, so as an example again, this is 45, 45, 90 triangle. I could give you an example where the hypotenuse is 10. I could give you an example where the hypotenuse is 8. I can give you an example where the hypotenuse is, I don't know, 3 square root of 5, whatever, right? But how about just make it simple? Hypotenuse is 1. Okay, how about if I give you hypotenuse here of 1? Okay, let's derive the remainder of the sides if the hypotenuse is 1. Well, if the hypotenuse is here, to get to this side, we have to divide the hypotenuse by square root of 2. So this side would be 1 over square root of 2. And then if you rationalize this again, like this, you get square root of 2 over 2. So square root of 2 over 2. And here, the side across from 30 is half the hypotenuse, so this is 1/2. And this side is going to be x times square root of 3. So this is square root of 3 over 2. So we realize the following. Okay, I'm going to summarize here before I finish this. Okay, there are two special triangles. The 45, 45, 90 triangle is x, x, and x square root of 2. And the 30, 60, 90 triangle is hypotenuse is 2x. The side across from 30 is half the hypotenuse. And the third side is x square root of 3. This is like a gimme mandatory information for, standardized testing type things, okay? So this is a 45, 45, 90 triangle, and this is a 30, 60, 90 triangle. And among the 45, 45, 90 triangle, the special scenario is the hypotenuse is 1. The other two sides are square root of 2 over 2 and square root of 2 over 2. And for a 30, 60, 90 triangle, if the hypotenuse is 1, the other sides are 1/2 and square root of 3 over 2. Okay, so these are special cases of right triangles. And inshallah, next time we shall build on this. Until then, assalamu alaikum.